Welcome to Physics Made Easy channel. Today we shall be doing configuration of transistors and then we may start with the characteristics. Now in electronics, if the basic logics about the circuits are clear, then there is nothing difficult, and if you want to cram the circuits, then it's very difficult. Simply, if we go by the basic logics, then things are very easy. So I will tell you how to draw the diagram, and first we should uh, do away with the issue of configuration of transistors. Now we need two input terminals and two output terminals, but we have got three terminals here: emitter, base, and collector. Three terminals: emitter, base, and collector. It means one of them has to be kept common to both input and output. If you keep base as common to both input and output, then we say that the transistor is common base transistor. Next, if you keep emitter common, for example, this is emitter, this is common emitter. Emitter is common to input as well as to output. If you keep emitter common to input and output, then we get common emitter circuit. And next is common collector. And if you keep this collector common both to input and to output, then we get common collector configuration. Now here we have got these three configuration of transistors depending upon the terminal that you want to keep common. If you keep base common, then common base. And if you keep emitter common, then common emitter. And if you keep collector common, then common collector. This is the circuit for common collector. Now the next case, in this way we have got three basic configurations. Three basic configurations. One is common base, common emitter, and common collector. Now one basic principle is emitter emits electrons, or you can say emitter emits majority charge, or they supply the majority charges. So first of all, we have got this common base connection. Arrow is in emitter collector base junction. Always remember this fact. Second cardinal principle, and then base is common, and this has to be forward biased. The very first step that we have to decide is to ascertain whether this is what kind of connection is it. Base is common and arrow is always towards N terminal. It means this is N and this is P and this is again N. Now emitter base junction should be forward biased. Forward bias means that P should be at higher voltage. Now this is N. N is it means it should be connected to the negative of the battery. This is connected to the negative of the battery, and positive end is connected to the base. Now emitter base junction is forward biased, and this ammeter, micro ammeter, is used to measure the emitter base current. And here input is FET, and this is cell or battery, and we call it VEE, and here is a resistance. So this cell is connected across emitter through a resistance, and this is an ammeter which measures the current IA. VEB is the voltage drop emitter to base. This is emitter and this is base. This is emitter to base voltage graph. Now the terminal which is kept common, here is a notation, the terminal which is kept common, that comes after. For example, base is kept common, VEB, emitter base. Here collector base is kept common. And now if we have a look at this circuit, this is the collector base circuit. We know that collector base circuit, this is collector base circuit is reverse biased. If you have to reverse bias this N, you have to connect it with positive of the battery. So this is positive of the battery. If you have to reverse bias this P semiconductor or the P part, you have to connect it to the negative of the battery. So this is connected to the negative of the battery. So in this way, emitter base junction is forward biased. Note down, emitter base junction is forward bias. EB is forward biased. Emitter base junction is forward biased. This is emitter, this is base. This junction is forward biased. This is N. How can it be forward biased? If N is connected to negative and P is connected to positive, then it is forward biased. This is positive, this is negative, and this is common base. On the other part, this is C. C is collector, it is connected to the resistance RC. E is emitter, it is connected to this resistance. Cell is connected to the terminal through a resistance to avoid short circuiting. Now, here again collector is reverse biased. This is N type, it is connected with positive for reverse biasing. This is P type, it is connected with negative. VEE is the cell voltage or battery voltage. VCC is the battery voltage in collector base junction. VCB is the ultimate voltage applied across collector base, and VEB is the biasing, or the VEB is forward biasing and VCB is reverse biasing. These are the batteries. And why is there difference between VCB and VCC? Because of this resistance RC and the current flowing through it. Same is here. The difference VEE, you can say, depending upon the direction of the current, ठीक है ना? So this resistance makes the difference between VEB and VEE. So here we join the input signal and here we get the output signal. Now it is advisable that you draw the diagram for P and B. Now if I replicate the diagram with different color for P and B, first of all that arrow will change. This is P and B. See, this is P and P. We have got a good example. Common base P and P. Arrow is reversed. Now this section has to be forward biased. So this is N and this is P. This has to be connected with negative of the terminal C. This has been connected to the negative. This has been connected to the negative. So this is P and B. This, no, let me make once more clear. For example, this is P. I am taking common base P and P circuit and making you understand its biasing. P should be connected with positive. Here it is connected with positive through this. This is B. for forward biasing, this is N. N has to be connected with negative, and this is connected with negative here. And current will flow in this circuit like this. It means this is at higher potential, HP at higher potential, and this is at lower potential. So obviously this portion is negative as it is joined to this also. So this emits the input, this measures the input voltage. Again, base is common, B is capped at end. Base is common, B is capped at end. Now this has to be reverse biased. This is P. For reverse biasing, this should be connected with negative part. So this is connected here with negative of VCC battery through this. This is base for reverse biasing. This should be connected with the positive part. See here, it is joined to the positive of the battery and negative of the battery. In this case, whenever you have to draw a circuit, keep one thing in mind, identify the kind of transistor, whether it is PNP or NPN, and simple logic, forward bias the emitter base junction and reverse bias the collector base junction. And in the next part, we have got common emitter connection. Now here we have got this emitter is common to both input as well as to output. Now this is N type, this is P type, and this is N type. This N is for now this is emitter is common. It means voltage will not, in this case common comes after. What will be the voltage? V, B, and then comes common. This is the input voltage. In this case, again, emitter is common. So output voltage will be VCE. These two things should be clear. And now this is the emitter base junction. It should be forward biased. This N should be connected with negative of this battery. For forward biasing, P should be connected with the positive of this battery. Here we get input. Here we get input. And now this is collector. And IB is the base current. And note down that input current is very small here. Because of this formula, we know that the base current is very much small in comparison to collector and emitter current. So this current is very small. So if this is base current is very small, so this should be microammeter and it will be milliammeter. It will measure current in milliammeter. Now, base emitter junction forward bias. This is P and this is N. This will be connected with the positive of battery. For forward biasing, this will negative. Now, hypothetically assume that we have got PNP. If this is PNP, then this end has to be connected with the positive of the battery. If this is PNP, we may have a PNP circuit in future. So again, the basic logics are quite clear. Base emitters junction or input should always be forward biased. Terminals of input forward biased, output reverse biased. And then notation for input voltage, common terminal will come in end. Here we have got emitter common, so we have got VBE. Here again emitter common, VCE is the output voltage and VBE is the input voltage. In this part, base is common. So VEB is the input voltage and VCB is the output voltage. Means the terminal which is common and symbol attached to that terminal comes in the end. Next we have got common collector circuit. In common collector, this is common. For example, let us identify the circuit. The direction of arrow is this. It means this is N. If this is N, then this is also N and this is P. Now this section has to be forward biased. For forward biasing, P should be connected with this is P and P. So for forward biasing, P should be connected with positive, and for reverse biasing, it should be connected with a negative. For forward emitter based junction has to be forward bias. P should be connected with, this is, we are taking this. So this should be forward bias. So here the battery connection is to my mind is not correct. It should be corrected. This is, if we take, this is collector based junction, if we go by that logic, then this should be reverse bias. This is collector based junction. It should be reverse bias. Reverse bias means N should be connected with the positive and this P should be connected with the negative. Collector based junction is reverse bias. Emitter based junction is to be forward bias. It means this should be connected with negative, which is correct. And this is common part. This should be connected with positive. So this is correct. So there is not any flaw or fault in it. So this section corresponds to input. Here you apply the input. From here you get the output. Again, this is common collector. So this voltage will be VBC. This is common collector. And this voltage here, output voltage will be VCE. No, opposite. VEC. Because the common part is collector. Notation is common comes after. So again this is V. On the top I have got E. And then this is C. VCE. So these are the three basic configuration. I strongly recommend all of you to write the circuits for example yourself without consulting your books or any notes. First of all for NPN common base and then NPN common emitter, then NPN common collector, and then repeat the same circuit for PNP. The only basic point, the basic funda is that emitter based junction should be forward bias and collector based junction should be reverse bias. And in this circuit there is a pitfall because this is collector based junction, it is to be reverse biased. This is P is connected with negative and collector is connected with positive. This is emitter based junction and this is emitter. Emitter has to be forward biased. For this forward biasing N should be connected with negative and this is correct. So in this way, I strongly recommend all of you to kindly go through these three configurations, draw the circuits, then proceed ahead. If you draw the circuit and keep the convention in mind that VBC common comes after, VBC is the input, VEC is the output because this is common collector. If this is common emitter, then VBE will be the you can say input voltage and VCE is the output voltage. If it is common base, then VEB, because base is common, VEB is the input and VCB is the output. Draw at least 4 to 5 circuits, 4 to 5 times these circuits and then proceed towards the characteristics. Before going through characteristics, this is input part. So graph between input current and input voltage VEB is input characteristic. Then graph between output voltage VCB and IC, they are the output characteristic. And how this IC is controlled by this VEB, these are the trans characteristics. So input characteristics deals with input current and input voltage. Output characteristics deals with the output current and output voltage. The two kinds of graph, input characteristics, input current and input voltage. Graph between input current and input voltage. Output characteristic graph between output voltage and output current. trans characteristics graph between output current and input voltage. So we have got two or three kinds of the major characteristics that we shall study in my next lecture. Thank you very much.